We will discuss three important concepts: specific heat, heat capacity, and molar specific heat. So we will start with these are the things. So we will start with heat capacity. Heat capacity, the definition: heat capacity of an object, heat capacity of an object is defined as the amount of heat required to raise the temperature by unity, that is 1 Kelvin or degree Celsius. So heat capacity is defined for an object, and it is defined as the amount of heat required to raise the temperature by unity. Okay, we will consider examples and try to understand in depth. So let us take a object. Let us consider that it is a 5 kg. Okay, we are supplying heat equivalent to Q1. Okay, similarly take another object which is of 10 kg. So we are supplying some amount of heat Q2. Okay, here the condition is there should be 1 degree Celsius rise in the temperature of the object. Okay, then we call that heat supplied as heat capacity. Okay, so for the first case, 5 kg, we are supplying Q1 amount of heat in order to raise the temperature of the object by 1 degree Celsius. Okay, for second case, we are supplying Q2 amount of heat, okay, to raise the temperature of this 10 kg of object by 1 degree Celsius. So heat capacity is nothing but amount of heat required for respective objects to raise the temperature by 1 degree Celsius. Okay, here the mass can be different. Okay, if I take different material, let us take copper 5 kg, okay, aluminium 5 kg. Here also let us supply heat. So here also we are supplying Q1 and Q2 different heats in order to raise the temperature of the objects by 1 degree Celsius. So even if you change the material, the amount of heat required to raise the temperature of the object is different. Amount of heat required is different. Okay. Next, let us consider specific heat or specific heat capacity. In order to define specific heat, we consider one kg of material. Okay, so then it becomes specific. So let us take copper 1 kg, aluminium 1 kg. We are considering solid materials. Okay, let us apply heat. So let us apply heat for copper, which is equivalent to Q1 and which raises the temperature of copper by 1 degree Celsius or 1 Kelvin. Now let us consider aluminium, 1 kg aluminium. Let us apply heat equivalent to Q2, which raises the temperature of this 1 kg of aluminium by 1 degree Celsius or 1 Kelvin. Okay, here in case of specific heat, we are considering unit mass of substance and we are supplying amount of heat which is making the substance or material temperature to rise by 1 degree Celsius or 1 Kelvin. This is known as specific heat. Okay, this is helpful in considering materials based on their application. So for cooling purpose and all, we can use different materials based on their specific heat. Okay, let us read the definition. The definition is specific heat capacity is defined as the amount of heat required or supplied to raise the material temperature by 1 degree Celsius or Kelvin. So here specific heat capacity is defined as the amount of heat required to raise the temperature of material which is 1 kg. Okay, so here 1 kg means unit mass of substance or material. So we'll modify this heat capacity definition and we will get specific heat capacity definition. So here specific heat capacity is defined as the amount of heat required to raise the material temperature. That is nothing but material here is 1 kg of substance or material temperature by 1 Kelvin or 1 degree Celsius. So this is nothing but specific heat capacity. Okay, so we are considering a unit mass of substance and we are supplying heat equivalent to Q1, which is responsible for rise of temperature by 1 degree Celsius or 1 Kelvin. This is nothing but specific heat of material. Okay, different materials have different specific heat capacity. Okay, for copper the specific heat value is around 0.39 kilojoules per kg Kelvin for copper, but for aluminium it is around 0.91 kilojoules per kg Kelvin. That means copper takes less heat input in order to rise its temperature, 1 kg of copper temperature by 1 Kelvin or degree Celsius. It takes less heat input compared to aluminium. So copper takes 1 kg of copper to rise the 1 kg of copper temperature by 1 degree Celsius. It takes 0.39 kilojoules of heat, whereas aluminium, which is of 1 kg, and if you want to increase its temperature by 1 Kelvin or degree Celsius, it takes 0.91 kilojoules of heat. This is how we can analyze specific heat. Okay, as we know, specific heat for water is 4.128 kilojoules per kg Kelvin. So for water, if you take 1 kg of water and if you want to raise the temperature of water by 1 Kelvin or 1 degree Celsius, you need to supply 4.128 kilojoules of heat. Okay, when we compare water specific heat and say specific heat of copper, specific heat of aluminium, we see that water has highest specific heat. This is the reason why we use water in say steam turbines or gas turbines. In steam turbines, especially in condensers, in order to cool the water which is coming from the turbine, because it absorbs more quantity of heat from the steam or the from the steam which is coming out from the turbine. So because the reason is what? It has highest specific heat.